Hi everyone, just thought I'd give you a quick update on how my project's going. Since I've last made my video, I've added a CMOS real-time clock, as you can see at the bottom of the page there. I've added a lighting tab, and I have the Wi-Fi working, as well as some improvements to the refresh speed and a few other things. Sorry, I was just grabbing a pen to play this, otherwise my hand will get in the way. Here we have your standard lighting things, a time for the light to come on, a time for the light to come off. Sorry, my camera's focusing there. And your on, off or auto. Here we can turn it on, which will be controlled by that relay. This camera is terrible at focusing with all this light. That's turned on this relay here. Of course you can set it to auto. The time increments in 15 minutes. Oh, need to work on the dead zones here. As you can see, it does roll over automatically from 12 back to 12 back to 1, sorry, and to 11. What other tabs do we have here? I suppose I could show you the settings page now that it's somewhat been done. Here we can clear all the predefined settings that we've done. We can calibrate the speed of the doses. This is using the MOSFETs down the bottom, and this is just the PWM speed. We can. I might not have the power circuit attached. I do. It's interesting that this one is saying 0. I really do need to work on these dead zones. As you can see, that one's spinning slower. At the moment, the minimum speed for each one, if at 0, would be half the speed, as it starts at 155, and I'm simply adding on a % for each one that they've added here, because the motors would simply stall if we had the PMW speed any lower than, I think it was 80. Anywho, that's the doser page. We can of course calibrate the E-tape. It's a bit of a boring page. Configure the auto drain. Now what this is I actually had to think about that for a second. What the auto drain is, it shows in the menu. So if we go back, if we have the auto drain set, say for every 7 days, the tank would automatically be drained and refilled with the amount of nutrients that we've defined in this tab. And of course, you can enable or disable it. Once it's enabled, we should have this tab being greyed out really. Really need to work on this button dead zone. That would be my next task. Let's find where it is. Come on, you're here somewhere. I fear that I've put it down too low. Let's try use my finger. It doesn't like the pen there. Well, that would be something to work on. How about these ones? That should be able to turn off. No, it really doesn't like my pen for these. Anywho, if we press that, it should go off. There is currently no debounce time for this, so that's why you're hearing it complain with a constant beep. I'm going to add a, let's say, 200 millisecond delay between each increment to stop that kind of thing happening. Now we can stop this silly alarm. Oh, wrong one. I'm trying to look for the camera. that was right. I could have disabled the beep, it would have done the same job. And let's disable that annoying LED. Man, these dead zones are terrible. So that's some settings there. So we've got the light. I've also got my heater tab. And what this is saying is if the temperature is lower than 20 plus the tolerance, so 21.2, or less than 16 minus, so 14.8, turn it on or off. So if we go back to the home page, our temperature is now 15.5. If I get my waterproof Dallas temperature sensor and hold it in my hand, with the relay in view as well, we should see it turn off at exactly 21.2. There we go. And if I let go, that will eventually cool back down. We'll hear it re-engage in a minute. What other tabs do we have? Oh, of course, we have the Wi-Fi, which is probably enabled right now, yes. And it says that it's sending every 30 minutes, but at the moment I have it set statically to 30 seconds just for testing. I suppose I should show you that. Oh, my back. Focus, you horrible camera. And it's quite a simple website really, it's just for testing at the moment. You can view the latest info, or you can view the history. So I'm trying to hold the mouse, the phone and sit on this keyboard, so getting the current latest reading. If we actually held that there for a bit, if you look inside, it is the current time, and it's sending them every 30 seconds. So eventually we're going to see a 16 tab. Let's click on the history, and it's all in ascending order. We will see a 16 result come on. Probably, I think I have my Ajax request refreshing every 30 seconds. I should make it a bit more advanced and actually tell it to go into the database and compare the values. There we go, that's the 16 value. I actually have a far more advanced website that I've made for a company that kind of uses this same model. And I'll chuck that in there. It's got an ascending and descending button, where I simply just say in the SQL statement, sort by ascending or descending. And I'll probably use a Google graph in there as well. Again, it's using Ajax and a web service. It's not actually directly connecting to the website for security reasons, which is always good. Suppose I can show you the response that the ESP is giving me. My server is just replying hello each time, and that's actually the response from the server. I use that for clever things, such as putting the update version in there, or even just saying update. You can use it to clear the values in the box, such as resetting the box's ID or serial number. Many other things. You all know what you can do with passing variables over. It's no different. Going back to the the Arduino. I suppose I could show you the ESP running. That's that thing there, lit up in colours. This phone really hates bright colours. I could try and focus, but it's just not having it. It's an ESP202. I suppose that's all you really need to know. What else have we got? I'll show you the settings, blah blah blah. The pumps you've seen before. It's pretty much the same as the calibration page. You just define how much of each you want it to dose. Actually, I forgot to put in the settings right now to define which pumps do which. It's meant to be that in the options you can say pumps 1 and 2 would do the EC, and pumps 3 and 4 would do the pH, or even pumps 1, 2 and 3 would do EC, or 4, and then this one can just do pH down. That's something very simple to add in there. I suppose I can show you how quickly it refreshes. It'd be interesting, it's meant to have a rule in it that doesn't seem to be applying right now. It says if I hold it down for more than 6 seconds, it's meant to go up in values of 10, which is interesting. Maybe it's because it's at its maximum peak. I should have a look for that. Basically it's just counting how long it's held for, and if it's held for longer than 6 seconds then start going down in values of 0.1 rather than 0.01. Something to play with. We've got our graphs as usual. This is the camera actually focused properly. I'll show you this is the EC graph. My probes are just in a cup of water right now, so they're not going to be reading anything interesting. pH. When the system first starts, it kind of gets a bit of a voltage spike. I'm using some LM117s to regulate a 12 volt power supply. It's a 2 amp power supply, and due to the amount of power lost, I think it's 11 watts, through bumping it all down, we run out of ampage really. I've got the volts but I lack the amps. And we've got our temperature. Again, this is just in testing mode at the moment. It's actually getting this every 10 seconds, which is far too quick. There is a time in the menu, the settings, to define how long to check for. That's the sensor check time. We've got our max mins, of course. 85 Celsius. Well, I don't believe that. I don't believe that at all. We should be having a play with that. Very, very naughty. Naughty, naughty. I shall have to be printing that out. I wonder how that happened. I have no idea. I can only think I might have accidentally touched a wire prior to this video, and it's got a high reading. We will find that out. Got the standard keyboard. I've put in some cursor things. Let's see if we can write hello. I pressed it twice. This hasn't got a debounce yet, so what that means is if I hold something down, it's just going to do it as quick as it can loop, which is very bad. So I shall simply put again a 200 millisecond delay once a character has been written to the screen. So right now it's so sensitive that you kind of get see, that was just half a second and it's already tried it 3 times. H. Ooh. We're gonna do it. H. Oh, I see what's happening. It's because I've got the beeper function running as soon as the display's touched, rather than when a button's been confirmed. So you get the impression that you've pressed it when you really haven't. With that in mind and remembered, I think I could do that. It's just, you just got to be assured that it has actually done it. Hello. Did we get that one? No. Hello peeps, we'll try and write. Are we at 10 characters? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we should be able to get one more in there. Yay! Let's click enter. With a simple debounce added in there, or basically just a delay once it's been reacting to each. Once it's been pressed by the button physically, we can fix that. It's only minor errors to fix, man. I've just really been trying to actually get the how to describe it. I've been trying to get the core functions written, and then I can work on this nitty gritty errors afterwards. It's only adding delays and the offsets of each button that definitely needs to be addressed. These screens have to be calibrated via software, so I think I've played with the calibration scripts since, and of course I've probably made a bit of an error. Have we got anything else to show you? We've showed you the temperature, the water levels. That's exactly the same as the other ones, isn't it? Yeah. That 2 needs to be centered. So does that 30. In fact, they all do, in fact, don't they? Oh, that's terrible. And this page, I simply haven't even touched yet. I want to have like a little triangle appear with the temperature icon or the humidity icon inside. So it'd be like a warning icon right here, and it maybe flash. And then when we click ignore, it should actually, you know, turn off the LED back to blue. Of course I've disabled the LED right now, but all the core stuff's there. The networking's working, the main function working. The only thing I haven't actually written yet, which is quite funny, is the algorithm to control the EC and pH. Though I have old projects that do both of them, and I understand exactly what needs to be required. What I can say is you definitely don't want each sensor reading within a hundredth of a second of each other. You need to let the electric field destabilize, so basically you read the EC sensor, wait a second, then read the pH sensor, and you have to account for pH drift. In other words, don't have your machine adjusting the pH every hour or even every few hours. Really you want to do it once or twice every day, because pH bouncing is absolutely terrible. It will kill your plants, it will kill your fish, it will kill any kind of life. Slowly drifting pH in one direction is fine, but it going up, then down, then up and down, no, that's very bad. And EC is very easy to control, but of course when you adjust the pH it's going to affect the EC, because basically the solution's conductive and it's full of positive ions. The tank will saturate with positive ions over time, so a hydro should always be drained no longer than every 7 days for NFT. Other ones, the nutrients can be recycled a bit, but really you need a good buffer in there. So like a seashell or something, you don't want to rely on pH up and down acids. Trust me, you'll kill your plants. So that's going to take careful consideration. Using a couple of timers, just basically to check when it's last done it. Obviously adequate time, and that's why I've left it to the user. I could have been really clever and actually told it to learn. So dose the tank, test how much it's increased, maybe add it, then tell itself, was that enough? No, let's add a bit more. Check again, oh it's still too low. So basically an auto learning script. But at the moment I've told it the user has to define the amount of nutrients that's going to be added. That's not, I pressed the wrong one. This is where you define how much nutrients is going to be added for the EC, and these are meant to swap from EC to pH mode. We're going to add that in. It's just going to be a button here that will say pH in EC mode, and it would either say disabled when you're in the EC mode, and when you go into pH it would say disabled, enabled, so on and so forth. I think I've covered everything really, haven't I? I haven't told you what sensors I'm using, but you can always ask in the comments. Some of the stuff I made myself, the RGB LEDs, the speakers, the ESP is just a generic 202 like I said, the display is an R8875, you can see that there, and the display itself is just a generic 800x480 TFT display with touch, 40 pin. That make there is definitely the best. I've got a few other ones that haven't worked with the driver board. Twin relay board, standard. That's the EC sensor. It's from a company in America. Very much recommend it because it's really easy to calibrate. This pH sensor, ooh, I don't like you. It's from China. Can we get it to focus? Not that I have anything against Chinese, but no instructions on how to use it. Half the outputs don't work, and it's been confirmed by the Arduino forums. And it's 5V logic, which is very annoying because I'd love to use a duo for this project. I've got like a whole plethora of bloody Arduinos and duos, and even more on the drawers and such. I think there's a couple of duos there probably. Yeah, there is. And some Unos, more Unos. There's probably a Mega over there. Some more Megas in the drawer. Point is, if I used a duo for this, it's I think 4 times faster. No, it's 3 times faster. It can run at 32,000 SPI. You get that screen refreshed 3 times quicker, and that would be lovely, wouldn't it? So, not to mention its process is a lot faster too. I think you could probably even get it well faster than 3 times. I was just accounting for the bus of the SPI. So in actually you could probably get 10 times faster. That's my notes on it. If you want any designs in the circuitry, I can give you some notes. And of course I'll put up the final version once I've finished it, but at the moment I have been writing my dissertation. I've got other classes to do at uni, so I haven't been getting a lot of time for my final year project. And if any of you are aware, a final year project's only worth 10% of that unit. So you don't actually really want to put much time into the project, you need to put a lot more into the dissertation itself. the feasibility reports. So in other words, I've gone well overboard with my project, but I'm guaranteed a good grade for doing so. Anywho, I hope you liked my video. Cheers for watching, and if you like what you see, subscribe. Thank you.